Screen share. Okay, we have done now. Okay, so sorry for the delay. Is the font large enough for you to see or not? Or should I choose it larger? Larger? And maybe 18 is better. Okay, this should be fine. So I wanted to give you a very brief introduction to Python. One of the things I always liked in programming languages are programming languages that you can pick up in half an hour to 1 hour and whose manual is less than 150 or 200 pages long. So for that reason, for a long time, I never wanted to learn Java. It seemed just too complicated to be a very good idea. Then I learned Java nevertheless, but I learned it essentially by coding. Python instead is a wonderful language. There is on the web, if you browse, I'll show you where the Python documentation is. Okay, so you can search for Python tutorial. Okay, you go to python.org tutorial. We're using Python version 2. There is a reason for this, but I will go into that later. Essentially, it's easier to use Python 2 than Python 3 right now to build the web apps. So this is a wonderful tutorial, and you can read it, I think, in a couple of hours, and it's extremely worth it. Normally introduction to programming languages are too complicated, but this one is really well done. So this will be your friend, and the other friend for Python is this, that when you go to Python documentation, okay, so this is the documentation, and there is a library, so you can find the tutorial and the library reference, okay? This library reference tells you all the libraries that are there for Python, and this is one of the very nice things about Python. These libraries are very well documented and very easy to use, and there is just about one library for every possible use. For example, what do you want to do? You want to compute cryptographic hashes of your text. Okay, fine. So you will search for hash, and you know, there are many ones, and then you find hashlib, secure hashes and message digests. You wanna, you know, do HTTP calls. You wanna connect to MySQL. You wanna do this. You wanna do that. I mean, there is a huge list of libraries. Okay, the list is really quite extensive, and each one of these is actually fairly well documented, much more so to my taste than in other languages. Okay, this is a simple one. This is deprecated, my lack of clicking, okay? But essentially here you can find all possible information about how to call these libraries. So these are the two main resources that you can use for Python, the tutorial and the library reference. What I will give you now is a very quick tour of the language, okay? So Python is an interpreted language. So if you create a file that is called attempt.py, then you can just say python attempt.py and it will run it, or else you can work in the shell. If you want to work in the shell, you do this, you install Anaconda, and then Anaconda is the best shell because it gives you something called IPython. I can say IPython, and here I am at the prompt, okay? And I can say A is equal to 2, B is equal to A plus 1, okay? These are interpreted as I type them. Print A, 2, okay? Print B. And you know, you can go up and rescue the previous command lines if you want. The only reason I use Eclipse is that it will enable me to write a file and then click on a button and run that file. So it's a bit easier for me for teaching, okay? But a word about development environments. So how do you write your code, okay? There are two choices. Either you use simple editors like Emacs, VI, and there are, you know, other fancy editors for Windows or Mac or Linux, etc. that you can use. But essentially, these editors edit one file at a time. Okay, these are great. I wrote code like that for a really long time. I was always happy. Nowadays, I actually go through the trouble of using Eclipse. Okay, Why do I do that? For two reasons. The first is this. I work on many things at the same time, okay? I don't have only one project. Now I have these, then I work on something else and switch back and forth. When I use Eclipse, I can essentially, when I save this Eclipse configuration, when I open it next time, I have all my files there already open exactly in the way I left the project. This saves me approximately, 5 minutes to 10 minutes each time I switch from one thing to the next. And for me, this is huge, okay? The other thing that I like about Eclipse is that a very silly but very important thing. If I highlight a variable occurrence, it highlights all the all the occurrences of the same variable in my code. So this helps me when I write big pieces of code. I mean, my files are typically not so big, and there are 1,000 lines, But if I have even 400 lines around, and I say, hey, where did I set this variable to the current value? Oh, there, okay, and I can go fix my code, okay? Much easier to maintain my code. But I'm not sure it's worth the investment for you. I'm just telling you because I find it particularly pleasant to use Eclipse also with Web2Py, because in Web2Py you will notice you have a lot of files. Every view is an HTML file, etc. So there might be some advantage. And if you want to do it, you have to install an extension to Eclipse that is called PyDev, and I will give you instructions on how to do it, okay? So with this, I concluded sort of this. Otherwise, if you're comfortable with Emacs and VI, it's a perfectly good way to start, or whatever else you like, okay? So this is a Python assignment. I can run it. I need to do this once and for all, and it ran. It just doesn't do anything. I need to add a print, I guess, before. So let me do this so it won't ask me again. Okay, so it prints 2. You see the output at the bottom. Okay, so fine, that's not very exciting. So, but you have assignments, quite obviously. And you have if then. So what are the data types? A is equal to 2. This is an integer. B is equal to 2.3. This is a floating point. C is equal to a string. Okay. And D is equal to another string. So in Python, it doesn't really matter if you use a single or double quotes for strings, okay? But there is a difference. If you use double quotes, you can put a single quote in the middle, and if you put single quotes, you can do the other. Like if you allow me a bit of my native language. This is nice in Italian, okay? So there is a single quote, and I can put it there because there are double quotes to terminate, okay? So, of course, you have the usual operators, okay? So, for example, you can say print A plus B, okay? And this just works, okay? I forgot the shortcut for run, but this just works. And let me see if I can figure out what the shortcut is. Well, okay, I'll figure it out later. And everything works normally, except for this. If I say print 3 divided by 2, what do you think I will get? You can comment things out, of course. What do you think I will get? 1.5. No, you get 1. So Python has this design feature that many complain is really a design bug, that if you do integer division, it gives you the quotient, the integer quotient, not the floating point result of the division, okay? So suppose you have 2 variables. So this is why this is a gotcha that happens fairly often. So imagine that you have these 2 variables and you say print A divided by B. Okay, when you say print A divided by B, you actually don't know what A and B are typically, okay? And so you say 0. Hey, this should be 0.6666, right? Not 0. So how do you do it? If you don't know what they are, but you want the floating point result, what you can do is something like this. So this is a silly way to convert a variable to floating point, after which you will get the result you expect. Okay? So so the normal operations work in the same way, but remember that integer division is a bit fun in Python. So otherwise, you have as basic types, you have floating point, strings, and Boolean. For example, you can say C is equal to false. Just to confuse you more, Booleans in Python are capitalized, and in Java they are lowercase. Just to make things easy, of course. So aside from these beautiful things, you have conditionals which work in this way. You say if, then you don't need any parentheses, and you can write your logical condition. For example, if 3 is greater than 2 and not C, okay? And then once you write this, you can write the block of code that should happen if this condition is true, which it is. Now, this is a peculiarity of Python. Normally, in other languages, you use braces. In Python, you use indentation. Indentation tells you what are the blocks of code, okay? So in this case, for example, I can say D is equal to, this is nice in English this time, okay? And print D, comma, C, just to show you some fun statement, okay? Okay, I can run these, okay? And it prints, well, these because I haven't commented it out. It was a bit silly of mine, okay? But if it prints, this is nice, and then false. So if you want to print multiple things, you just separate them by commas. This is a quick and dirty way to print stuff, okay? So it works fairly nicely. So what if you want to close this block, right? You do it in this way. You say print after the block, okay? And this will be printed after, this will be run regardless of the condition is true or false. So suppose, for example, I do this. In this way, of course, the if will fail, but the after the block is still printed. So indentation rules, normally people indent by 4 characters, but Python, the Python interpreter is smart enough to try to understand what's the indentation you're using. If you do silly things, like if you miss by one space, it will either complain or do funny stuff that you are not able to predict, and you will be in trouble. Some people hate it, that there are no braces, and some people love it. The drawback is, as we have seen, that if you need to embed Python in something else without braces, in fact, in the views, we have to use pass to terminate a block. Okay, so essentially, from a theoretical point of view, a language in which the formatting matters is crazy, right? You want to be able to remove all the line breaks and still the things should be the same. In practice, though, I work with a lot of other people, and it's very nice that Python uses indentation for blocks, because it means everybody is forced to indent the same way. If you read somebody else's code, you know, and you cannot hammer them if they indent it wrong, it's sometimes a real pain to see the kind of mess that other people sometimes do, and this keeps them straight. So it's very easy to read other people's code in Python. That's a big advantage. So okay, so we have ifs, great surprise. What are other data types before I go to loops? So one of the incredibly beautiful things about Python compared to other languages is that it has a few but very well thought out data types. So there are other data types in addition to these elementary ones. One is a pair. So I can say a pair, and I can say, for example, for cat. Okay, this is a legitimate pair. I can also have a list, which is they don't, contrary to Java, a list can contain heterogeneous types in it. Python is a runtime typed language, and as long as you fish out the elements out of an array and you know what they are, each one of them, you don't run into trouble. But needless to say, if the list is variable length, it's not a great idea to mix things of different types. So I won't do it this time. But for example, I can put in a list A, C, T, dog, and I don't know, bird. Okay, something like this. This is as good a list as any. Okay, so there are pairs or tuples in general. Okay, a tuple, 4, 5, 6. So what's the difference between a tuple and a list? A tuple is immutable. Once you define it, that's it. A list is mutable, meaning that you can always add an element to it. Or remove it, or it's dynamically, you can change it dynamically. Also, you can do this very nice thing. You can say A, B, C is equal to a tuple, and this takes the tuple apart. Print A, B, C. Okay, so let's try this code. And 4, 5, 6. So it built a tuple out of 4, 5, 6, and then it took it apart. So if you need to write a function that returns two variables, two values, you know, which is a pain in Java if you tried it. No? How do you return two values in Java? Oh yeah, you create an object that, of a pair, whatever, which is an object, horrible. Instead here you say, hey, return x comma y, and you're returning a tuple of x and y. Yeah, and when you call this function, let me do it in fact, okay? Let me define a simple function that takes a tuple, okay? So I can say, how do you define function? You say def and the name of the function. Def f of x, y, okay? Return, I don't know, x plus y, x times y. Sorry. This is a valid function definition. What it does is that, well, it has parameters x and y, and it's returning a tuple. Python is somewhat sloppy in syntax, so in some cases, the parentheses around the tuple are optional. This code might be clearer to you if I wrote it like this, but these parentheses are not actually necessary, okay? And people customarily don't put them in return statements. But you're basically returning a tuple. So now I can say ZW is equal to function of 2, 3, okay? And I can say print Z and W, okay? And this will just work. Oops, sorry, my autocompletion is a bit aggressive, okay? 5, 6, which is, you know, sum and product of 2 and 3. So very easy to do this kind of things. So tuples are used basically for this. You know, you have a few things that belong together. They may be of different types, but you want to pass them around as a unity. Tuple is your solution. List instead is for variable length stuff. And list, you know, you have you can do many things. For example, let me comment out these, and let me say a list. I want the third element. This works obviously. Okay. Great, yeah, it's a dog. Now, I can also do various things. So, for example, I can say a list append, and I can say that I want to append a cat, which is the missing obvious animal on the net. Okay, well, I should say print a list. Okay, and by the way, notice how easy it is. Python knows by default how to print every object that you create. Any value that you create. It's not like Java, in which you have to define a class for everything and then get bored to define, you know, what is it called? What is it called? The print method? No, a wrapper method. I forgot. You know, I use. I'm a bit fuzzy on what is it called in Java? Sorry. ToString. Okay, thank you. Yes, I'm sorry. I use various programming languages and I mix them all in my mind. Because in Python it's called the represent if you define a class and you want to define a special representation, okay? But Python is incredibly nice. It knows how to print stuff even if you don't tell it to. It has the right defaults, sort of, okay? So the way it works is that a list knows how to print itself, and it calls recursively the representation function of the elements of the list. So everything magically works. So let me, so you can append things to a list, you can get elements out, you can a list extend, and you can put a whole list here, you know, the 3, 4, no, this would be bad, you know, from typing rules. I mean, it would run, but it would not be pretty. Okay, and I can print, or I can do these, but I can also do print a list plus a list. So the plus works for lists, okay? And you get, you know, the sum of the two lists. So lists are incredibly convenient in Python. Let me tell you why. They are implemented in an extremely smart way. So a list is at the same time a list and an array. The time you need to fish out an element in a certain position does not depend on how far it is in the list. But yet the list is dynamic, so you can extend it, you can put elements in the center, you can remove elements from the center, you can do every kind of operation that ever jumps in your mind to do, okay? For example, I can say B is equal to a list pop 2, and this will just remove, now we have too many prints, okay? But let's just keep these 2 and remove these, okay? You see, I just popped out and removed the element 2. Actually, I can do these, and so you can see exactly what happens. You see, I removed the t from the list in this way. Oh, I should have done these, I guess, to make it more obvious. You see, I remove the element in position 2 and I pop it out. So it's extremely flexible as a data structure. Okay, so it's a fantastic gift. In fact, let me erase a little bit because we have too much stuff, and tell you. So tell me a complicated data structure, maybe a binary tree. I can build it on the command line in Python. So what is a tree? A tree is one of these things that has a node, and every node has 2 children, and the children can be either leaves or nodes, and this way would be pretty boring, but in every node there may be a value, okay? So, there can be, whatever is the tag of the node. So how do you build that tree in Python? Well, that's easy. My tree is equal, and now I will use tuples. And I will describe each one of these objects simply. Each one of these things will be label, comma, left, comma, right. Okay? There is a special value in Python that is called none, which means none. It's a bit like the null of Java, but it's sort of, I don't know, better behaved in my opinion. So let me do a tree like that one, okay? How do you write it? Well, the top element is A, and then has a left branch, and then it has a right branch, okay? The left branch contains, what is it? A B, okay? And it has no children. And the other branch has a C, and it has no children, okay? Now, let me do a function that works on a tree T, okay? What do we want to do on this tree? Do we want to do a print it in pre-order, post-order, all these complicated things? I think that algorithms at UCSC should be taught in Python because it would focus you on the mental part and not on the code. That becomes very easy. What do you want? In order, pre-order, whatever. If T is none, return. This is a bit silly to write, but I want to avoid being, how do you represent the null tree? I mean, so it's not silly to write after all. Otherwise, I can say that, how to say, tag left, right is equal to T. So I take the tree apart, okay? And now I can do anything. What do you want? Pre-order, post-order? For example, I can do f of left, okay? Print tag f of right, okay? Something like this, I guess. This should work, okay? So f of my tree. So let's see if I got it right. BAC, okay, that's right. Okay, BAC. Fine, great. So you see, you can go a really long way with lists and tuples that can contain elements of any type, and you can build a lot of other stuff. What's a graph? Well, what's a graph? Good question. Well, the edges are a list of pairs, right? And maybe you want to keep a list of pairs that represents the edges and a list of vertices, and that's it basically. Okay, that's a somewhat stupid representation, because if I represent a graph in that way and I tell you what are all the edges from this particular node, then you need to do a linear search in the list of edges, okay? So there are better ways. So, and to do these better ways comes to your help another one of the data structures of Python. Namely, it's called a dictionary, which is essentially a hash table. It's written in this way, okay? My dictionary D is equal to a cat has 2, and a dog has, okay, more interesting. A cat has 4 paws, and a snail has 0, okay? In theory, you should don't need the final comma my habit is always to write a final comma so that if I need to add one more line, it's easier. All the lines look the same. Okay, that's a silly trick. Okay, and then I can say print d of cat. Okay, so this creates essentially a dictionary is a hash table, and this will print d of cat, which is 4. And I can also say print d dot keys, and this will print all the keys in the dictionary. Okay. And I can also do print d dot values and similar things. Okay, d dot values is the values, and the most interesting thing is to do print d dot items, which prints a list of pairs key comma value. Okay, so these dictionaries are implemented very, very efficiently. So if I were to implement a graph, what would I do? Well, I would implement a list of vertices. Okay, actually, I could do it with a single dictionary. I would have as a dictionary in which the keys are the nodes, represented by integers, for instance. Okay, and the values are lists of nodes to which there is an edge. As simple as that. Okay, let me build a graph to you on the command line. But then I am not sure I want to print a graph, do a graph algorithm on the fly. I mean, I could actually, it's not so hard, but my graph G is equal to this. Node 1 goes to node 2 and goes to node 1 itself. Node 2 goes to node 3 and node 1 and node 3 goes to node 1. Okay, something like this. Very, very interesting, as you can see. But I can see 1 goes to what? 1 and 2. 2 goes to 3. And 3 goes to 1. Okay? Very nice. So, suppose I have something like this, and I haven't told you any flow of construct. There are while and for statements. Okay, so let me try again with a simple example. A list is equal to 1, 2, 3, 4. So this is a list, and then I can do for n in a list, print n times n. Okay, very deep code, and this works. Okay, so this is how you do a for loop. A while loop is very similar. I can say while. Well, I have to do something before, like I is equal to 0. While I don't do this. Okay, it's a stupid way to do it, but I can do it nevertheless. Okay, so this is not a particularly smart way of writing that code, but it works. Okay, so just for you to show. So you have for, you have while, you have if. You don't have repeat until, but you can mimic it with while if you can sort of wrap it around. One interesting thing that you have in these statements is also this print range of 10. This will print all the numbers from 0 to 10, so excluded. Okay, so and so you can easily do at this point for I in range 10. Okay, and I can say, for example, print I, and then I can say if I is greater than 5, break. So break is one of the statements. You have break and continue. If you write break in a loop, it will just get out of the loop right there. So you see, once you reach 6, it stops because of the break. Okay, so this is a bit of control flow. So suppose you have this dictionary above. A very typical thing you do on the dictionary is this: for key comma value in g dot items. You remember that g dot items is this list of pairs that form the dictionary, right? So let me do to be easier for you. Print g dot items. So you see on what I'm iterating, okay? But g dot items is this list of key value for all the dictionary, and then you can say print the key is k, and the value is not very smart, I know, but whatever. Okay, and so this is a very common way of iterating over dictionaries. Okay. Now there is another thing that I forgot to tell you about lists that is pretty convenient. So if you have a list that is equal to, for example, 1, 2, 3, 4, 5, 6, there is this beautiful construct that is called slicing. So you can say, give me of a list. This will give you the element number 2, okay? 0, 1, 2. But this gives you the elements from 2 onwards. Okay? 3, 4, 5, 6. Okay, because the element 2 is actually 3. Maybe it would be more obvious if the list started from 0, and then you would see what you expect, I guess. Okay. So all of these things, I just give you a preview, but they're written also in the tutorial, right? I'm just giving you a sort of preview of the language. This is very easy. You can say also, give me all the elements up to the 4th. Okay, and you can also say print a list from 2 to 4. Notice how the element number 4 is excluded, actually. Okay, so in Python, when you slice something, if this is your list, okay, the way it works is this. If you say element number, these are the numbers of the elements. But if you say element number 2 to start is like this. Element number 4 to stop, it's like this. So it means that the list goes from here to there, which is very beautiful, because if you say, look at this, what is 4 minus 2? It's 2. And so the length of the thing you are getting out of this slice is 2. You don't have this silly plus minus 1 error. So if you start from 1 and you stop at 10, there are not 10 minus 1 elements, but there are actually 10 elements. Not 9, but 10. So it's easier for these plus minus 1 errors, Python, in some way, I find at least. Okay, slices are incredibly useful for another reason. Assume that my array is actually a little bit too short. What will happen? Will this bomb throw some incredible error? What will it do? Nothing bad. So the slices are very error tolerant. If you try to get a slice, but there are not enough elements, you simply get a smaller result. Very handy for avoiding bugs. Okay. So whenever you can, don't do a loop that says, "Oh, I get the element 5, 6, 7, 8." Because if you do that and there are not enough elements, the code will break. You will get an index error in a list. If you use a slice, you're safe from that. So this covers, okay, so once you have hash tables and lists that you can use both as arrays and as lists, you can implement pretty much any data structure. Are you convinced of this or not? Or if you're not, tell me a data structure and we try to encode it. I mean, there might be some matter of efficiency. So if you want to work on very large numerical matrices, you can do it because it's a list of lists. But then there are better things to do, like you can use NumPy, which is a numerical package for Python that does it better. But I think that out of these elements, basically, you can build whatever you want. And not only you can build it, you can build it on the command line and you can print it in a way that you can immediately read it. Much easier to debug than Java. I mean, I love Java for other reasons, but what are the problems of Python compared to Java? It's not typed, so until you run it, you don't know that it will work. Now, for web systems, this is a problem, but not a very large one, because when you do a web request, it usually has to run quickly, and so you can do tests fairly quickly, otherwise you have major other trouble. Once upon a time, I wrote a very large piece of Wikipedia analysis code originally in Python, and that was a nightmare, because it would run for half an hour, and then somebody uses a crazy stupid accent that I didn't expect to find, and it would break my XML parsing or whatever. And my code broke after half an hour. And this was so maddening that in the end I wrote all my system in a strongly typed language so that I could actually, have some compile time sanity checks whenever I changed it, because it was getting too much out of hand. Okay, so but in general, I have good experiences with both Python and Java. When I write Java for Android, and I think it takes more time to write. It's less pleasant to read. You write 5 times as much code to do the same amount of stuff. But if you need to rehash your code, you break it less often because it's typed. So that's a super quick summary of my personal impression. By the way, I'm teaching you web in this course, and I will try to teach you how to. I will teach you also how to embed web pages into apps that you can put on the app stores. But it's an interesting signal that I was talking to various people in these days, and mobile is overtaking the web as the most common used platform by people by far. And web might be 1 billion people, but mobile will be 6-7 billion people soon. So mobile is very important. So just to sort of the world is changing. Sometimes, the web might end up being the old way of doing stuff in a while. Okay. What else do I want to do for Python? So you can define functions. Functions can have optional parameters. This is very, very useful. For example, I can say define f of x. And then I can say increment is equal to true. I'm defining a parameter increment that has a default, okay? And then I can say if inc return x plus 1. Sorry if this example is so silly, but else return x minus 1. Okay? And this is very handy because I can then say print f of 3, and I can omit the additional parameter if I don't care about it, okay? Or I can say print f of 3 inc is equal to false. In this case, if they're optional, you need to name them and call the function using this syntax. And if you do it, if you run this code, it will be 4 and 2, okay? This I find it extremely useful. It's a lot of times, you write a function in which normally you want a behavior, but you want to give it a flag so that in that particular call it does actually something else. And in other languages, you have to carry this parameter between your feet all the time. The other reason why this is useful is that sometimes I use these name parameters. This is not a strongly typed language, okay? So imagine that you have to pass 10 parameters to a function. What's the chance that you pass them in the wrong order? Very high. So if you use them as name parameters in this way, there will be much fewer chances that you actually make a mistake, okay, in passing the parameters. Okay, so it's recommended also for that. Okay, yes?
If you have multiple name parameters, can you call them in any order?
Yeah, so the positional parameters need to be passed in the same order, but these boo is equal to 3. And so I can say, okay, something like this. Okay, and so I can say, let's see. Okay, so this works. Okay, in fact, you can also do things, but don't do it. I think it's a really bad idea. You can also do printf of 3 false 1, and this will still work, but it's really bad. Don't do it. Okay, so essentially you're using the name parameters trusting the order. Yeah, it's boo is equal to 3 by default, but this is a really bad idea. Okay, so don't do this. This is like shooting yourself in the foot, because you're not supposed to pay attention to the order. So these are functions, okay. So aside from these, a lot of the power of Python is given by libraries. For example, libraries, some of them come with the system. For example, you can add the strings. You can do, I don't know, print s plus cat, and this will work. It will give an oops, sorry. Yeah, well, whatever. Okay. What else do I need to tell you? So, yeah, what else is there in Python that is interesting? There are objects and classes, okay? You don't need them a lot to build web code. Because in web code, you know, when are objects and classes very important? Objects and classes are important when you are building these things that have a personality and are persistent for a long while. But in a lot of the web coding you're doing, you don't have anything persistent. You know, you're getting a request, you're doing this, that, and you're returning a reply, and that's it. So I find that I don't write a lot of, you know, object-oriented code when I actually write short request servicing. But I want to at least tell you how classes look like. Okay, they are very simple actually. I can do these. I can have a class table. Okay, and here in parentheses I say object because I just want to extend the most basic class. Okay, so and then I can say def init. This is a silly way of writing it. This is a class initializer. Okay, and I can take a width and a height, which by default. What is it in this for tables? 28 inches, I believe, is a common default for a table. Okay, so this is my initializer method. So what is this funny thing self? So different from Java, in Java when you have a method, the method knows to which object it's applied. So, okay, and so if you say this is a method of yourself, it knows what yourself means. In Python, it doesn't know. And so you pass, when you define a method, the first argument of a method is the object to which the method is called. Okay, the destination of the call, if you will. So suppose I want to store these two elements, width, depth, and height, these three elements inside my table object. What do? I define object variables. So self width is equal to width. Self depth is equal to depth. Self height is equal to height. Okay, so why am I doing this apparently silly thing? Because this width is simply the parameter of the initializer, you know, is a formal variable, right? Whereas a self width, I'm creating a variable called width associated with the object self. And so this is the way you store you store object variables, okay? And then I can do, sorry if it is a bit silly, but I can do a volume method in which I only get self. Okay, I don't need to do to get any parameters. Or maybe I can get a typical example in cubic centimeters is equal to false. Okay, let me write a method with an optional parameter. So I can say v is equal to self width times self height times very surprising code, self depth. Then I can say if in cubic centimeters. Okay, what's the conversion factor between cubic centimeters and cubic inches? No, that's between an inch linear. So we need the cube of that. Yeah. Okay, so I have a calculator here, 2.54, 3, okay, so 16.3871. V multiplied by 16.3871 return V. Okay, so and then I can say my table is equal to table of I don't know, I want a table that is a 4 foot width and has a depth of 2.5 feet, 24, 30 inches. Okay, so that's my table. I don't need to specify the other parameter, and I can say print my table dot volume. Okay, and then I can say print my table dot volume, and I can say in cubic centimeters is equal to true. Okay, so I can do this, and this will give me the two replies. Okay, so objects are very simple. There is no way, such in Java, to define private methods, private object variables. You can shoot it yourself in the foot as much as you like. Okay, you can define a variable that is super private and then just use it. Okay, so traditionally, if you have a method that is supposed to be private, you do it in this way in Python. But this is simply a tradition. It's nothing like def. Don't call me. Okay, that takes a self and takes I don't know, a variable a, and this does like print I don't know, or you know, whatever it does, pass. If you don't know what to do, you say pass. This is a void instruction. Okay, but so this initial underscore is a signal that you're not supposed to call it. The double initial underscore is a signal that, you know, these are special methods. So there is an init method, and if you want to represent stuff, you can say def represent self, and you can say return. You're supposed to return a string. So you can say, I am a nice table of size, and this is how you can. Oh, actually, so normally, you know, there are these format strings, but I want to tell you the one thing that you will need for the web. For the web, you only will print if you want to debug, right? You're not printing other stuff, typically. So you can read about format strings, but the most useful format thing is R. This tells whatever it is, try to represent it as a string and be done with it, and don't bother me with other questions. I don't want to know if it's an integer, a float, or whatever. And this is very useful in debugging, because if you're debugging, often you don't know what's there. You know, that's the very reason you want to print it. So you do. So just to show you how it works, okay? You do these times these times these, okay? And you can say these. And I have multiple parameters, so I have to say self, sorry, it's a bit verbose. Oh, okay, so there are two styles of breaking lines in Python. The stupid style, sorry if I have to be so vocal, but many people use it, but I think it's completely a bad idea, is to use a backslash and then go change line. I think this is a, okay, expletive idea. Because, why? Because if that, after that backslash, somebody ever adds a space, it will not continue the line anymore. So I'm okay to have the meaning of my program depend on initial indentation, but to have the meaning of my program depend on blank space at the end of a line that I can't see, no, that's foolishness. Okay, so people should be hammered for doing that. Okay, so sorry, but some ideas are just completely crazy. So you don't do this. In Python, every expression by default is only one line. What? Yes, it's really true. But if you open a parenthesis, then it waits until you close it. So that's a nice trick. Self width, self depth, self height. Okay, so this will work. And so I can say print my table, and this will then work, like, you know, as in Java, I suppose, sort of. Okay, so that's very nice. Are there any other deep things? So of you? Sorry?
Maintaining a global variable within class. It's represented.
Oh yeah. I mean, sorry. You can do all kind of incredible things to an object. For example, I can say this. This is you know, my table dot width is equal to 1. This will work. Ag. Okay, so this seems like a silly idea, and often it is a silly idea to do this, but often it's not. For example, you can also say my table color is equal to blue. I'm doing something a little bit crazy if you're used to Java. Well, it will not be in the representation string, but I can say always do print my table.color. It will not be, you know, a part of the representation. And so this will work just fine. So I actually do some of these, and people really do some of these. I mean, when I talk for the web, I mean, I was using an example a few days ago. Okay, I tell you the real example where this was happening to me. I'm getting an object from a browser that contains a representation of a user interaction. So what the user did with the mouse on the web page, okay? And they told me, no, did the user click on this image? Did the user look at this image? Did the user do this or did the user do that, okay? And so I get an object. And as I get the object, I'm trying to compute more properties of the user interaction. For example, the user interaction contains, this is for an application in which the user is looking at webcam images, okay? So there is a frame, and depending on where the mouse is, you can scroll images back and forth. And so the user interaction contains, all the images you saw and when you saw them. And then I want to say, how long the user was looking at this particular image, okay? We do this to try to do machine learning, but that's a long story. But so I want to compute these additional quantities. That makes sense only for some user interaction. If the user interaction is that the user did something else, it may not make sense. So I do this complicated calculation of how long the user has been looking at, and then I say UI dot engagement length is equal to my result. Okay, and some UIs will have that engagement length variable, and others will not have it. Okay. And so it's very useful at times having essentially these homogeneous objects. Okay, so in Java you can do that. You have to define what is your set of private variables. In Python, it's dynamically typed, and you can have objects that have different sets of private variables. Okay, if you are not careful, of course, that's a marvelous way to shoot yourself in the foot because you expect something to exist, and if it doesn't exist, for example, if I write a British spelling there, I will get an error, right? And so these kind of things happen. But if you are careful, it's very useful to be able to add and remove attributes from objects on the fly. Okay. Now, a couple of things that will be extremely useful for you on the web. So one of the issues is this that you have in every language. Now I define again. I wish I still had it. But I have my tree that was done by A, and then there was B, and there was none, and then there was a C, and then there was a C that had a none, and maybe the other leaf was actually, maybe this label was a string 2, 3, 4, and none. So suppose you have something like this, okay? So this is my tree. Fine, so I can do print tree, and this is a data structure, so fine, I print it. But often you have this kind of stuff, and say you want to write it in a database, or say you want to pass these to the web interface, okay? So databases don't accept trees as input or things like that. They accept strings often, okay? And same for passing stuff to the web. When you send something back to the web, well, it's an HTML page, but otherwise you can send, pieces of text to it. So the question is, how do you quickly and painlessly take something and translate it to a string so that you can do the back translation painlessly? So there is a module. There are many, many libraries, as I told you. And this is how you import libraries. Import JSON. Okay, JSON is a library that translates objects in Python back and forth to the JSON, which is a JavaScript simple object notation. So it's essentially, a quick way to turn things into strings. Okay. So what you do is this. S is equal to JSON.dumps of 3. Okay. Now I can print S, and then I can say A3 is equal to JSON.loads from S. Okay. I can print A3. And I can also print 3 is equal to A3. Well, let's see what happens. Okay, so let me do a bit better. Okay, so I explain you what happens. So this was my original tree, okay? Sorry, no. It's let me do it. Let me do it a little bit better. Okay, original. This is the original tree. This is written in JSON. And then, well, let's leave this. Decoded. Okay, so let me do it this way so it will be clearer.
Original is tree, the other one is gate.
Yeah, sorry. Okay, so this is my original tree. Then I encode it in JSON. JSON, you know, is interoperable between Python, Java, C++, JavaScript, many other languages have interfaces to it. So, you know, we cannot expect that RAM parentheses are preserved, but essentially tuples and lists get turned into these brackets. Okay, so essentially JSON understands lists and translates tuples into lists automatically. Okay, just because list is a bit more general. Okay. But this is the JSON representation. So none is represented as null. Okay, and once you decode it, you get well almost the same thing. There are two differences there. One difference is that the tuple has been translated to a list. Okay, fine. The other difference is that this A has been translated into Unicode A. So Unicode is a representation that essentially enables you to encode, you know, more characters than the usually ASCII ones, and so JSON translates back to Unicode everything it receives. So the two are different because, of course, tuples are not equal to lists. If I wrote these, sorry, I cannot edit that, but if I wrote these using lists, so if I write everything using lists, so the decoded, you know, looks different because now it's Unicode, but Python is still cauterous enough to tell me that the two strings are equal. Okay. Now, Unicode is something that I would rather not explain now, actually, because it's a bit of a mess. And it's the reason why there is a huge controversy in Python between Python 2 and Python 3. Python 3, every string needs to be either a byte string of which many operations are missing, or it needs to be Unicode, in which case you need to say Unicode with which encoding, because unfortunately there is not a single Unicode encoding. Otherwise, everybody would be happy. There is Latin 1, UTF-8, there are many ones. And you can only, you know, do stuff together with the strings of the same encoding. This was a beautiful conceptual construction, but the problem is that on the web, you get stuff whose encoding you don't know, because you don't necessarily know easily who is talking to you on the other side. And so adapting many frameworks for the web to Python 3 and its strictly Unicode implementation is not pleasant. And so, so actually, many platforms and many frameworks still support better Python 2 than Python 3. Okay, but this is a fantastic way, and you can handle also dictionaries. So you can handle essentially all the basic types plus lists and dictionaries. For example, I can say print JSON.dumps of my dictionary that had a cat 2 and dog 3, and this will just work. Okay, this is actually it's the same as, looks identical as in Python, the representation of a dictionary. So you can send back and forth the values between the web and your server in a very easy way using JSON. It's understood both by JavaScript and by Python very easily. So at this point, this is all you need, I think, for a very beginning level of Python. Are there any questions? Shall we? Yeah.
When you define a class, what happens if you try and print it but don't define the representation function?
You get a number representation. You get the object at, and it tells you the hex offset in the memory where the object resides. So it's unfortunately not very nice. It would be simple because Python, like Java, if you do it deep enough, but Python has these introspection methods. So there is a way in which you can actually loop over all the elements of an object and print their values. Actually, I don't remember. I don't know if on the fly I can remember it, but I think it's called self dot underscore underscore dict underscore underscore. Something like that, okay? I mean, I would need to look it up because I don't use it often, but there is a way in which you can get the dictionary. When you say, for example, self.a is equal to 3, this creates a sort of entry in a pseudo dictionary that says, oh, okay, now there is something a that is associated to 3, you know? And so you can fish out all the names of all the object variables, and you could define a better one. I don't know why they don't do it by default. Maybe because you might risk getting too large an answer. I'm not quite sure.
Other question is, when you define something like table.color on the fly, is there a way to see if that's been defined for an object or not?
Yes, but it's not so easy. But if you want to do, yeah. Yes, but you can do it because you can do it get at of an object and you can see whether it's there. But it's a sort of painful method. There is a very elegant way of doing this kind of things, but I don't know whether to present it to you or not. So. Yeah, let me tell you later, okay, about these. Maybe I'll do a small parenthesis another time. Now I just want to have one more word on dictionaries. So if you have a dictionary, there is a difference between saying the hello. Okay, this will break obviously. Okay. And instead, if you are in these situations, you can say the get hello. This seems is almost the same, but if I do print of these, but you get none. Okay, so this will work. Oh, and you can also do print cat in D. Okay, this will cat in D tests whether cat is a key of D. Oops, yeah. Okay, so it will tell you that cat is an element of D. So you can test for belonging very easily. I forgot to tell you there is another data type that is a bit more specialized in use, but is a set. You can say S is equal to set, and you can say s.add cat, and you can say ask dog, I guess print dog in S, which should be false as okay, and so there is a type of elements. There is a set type that is incredibly useful because contrary to, I mean, what's the difference between a set and a list? You can also ask whether things are in a list. I can also, if I have a, this is why lists are so flexible, okay? I can also say, for example, another version of S would be to write cat in this way and also maybe put a bird in it as well. And I can say print cat in this version of the string, and it will tell me true, okay? So I can do this with lists as well, but the difference is that sets eliminate duplicates. So if you need to have something that has no duplicates, then the set is the obvious thing, okay? And you can loop on a set very easily. For x in the set S, print x, and this will just work. So all these works very, very easily. And you know, we will do more things based on examples, but this is enough. Any other question? Otherwise, we might as well start, I don't know, writing some code, for instance, or doing some things like that. Okay, so I got a question. Should you install the source package, or should you install the executable of Web2Py on a Mac? So you can do whatever you want. At the beginning, it's easier to install the executable package, I guess. Okay, so you can do it for the first couple of weeks. It's not a big deal in the sense that even if you can even install two. I have both installed on my laptop. Nothing really bad happens, right? In fact, if you start writing some code for one version, you are writing an app. Then you can click on the button to download your app. Then you can launch the other version of Web2Py, and you can upload your app into the other, and there you are. Okay, so I mean the code will just work. So so you can switch from one and the other. The real advantage of the source code one, even though it's a little bit more of a pain, is that not today, but probably this afternoon, I'm going to post to the web page a starter app from which you can start that is a little bit better than the standard Web2Py one. The standard Web2Py one is very simple, but I want to give you one that defines also logging in such a way that if you say log these, then you get a log line that says these in your output, and that I find extremely helpful. And so I want to give you this sort of starter package that works a little bit nicer for debugging essentially, and that will work only if you use the source code. But you can use whatever you want. In fact, now because I want to be fast, I just launch again here the Web2Py one. And I do okay. So are there questions on Python, or should I move? I move to the web then development again. So there is one thing that you can that you need to know, okay, to develop for the web. Suppose you are looking at a web page, and if you don't mind, I get a web page that I know how it is done because I know it's very simple. So this is a CrowdGrader web page. I wrote it, so I know how it looks like. Okay, so you can be in these, or you can also be in these. Okay. But one of the things that is very useful that you learn to do is this. Suppose that you are the author of this stuff. And now you wonder, hey, why is that thing there looking in that way? And also, why is some information missing, and where are the bugs of what I'm doing? So essentially, how do you debug a web page that you are getting? And I advise you to use one of these two tools, or both, actually. Either Chrome, or you can Google for Firefox Developer Edition, and you can download. It's a special version of Firefox that will not interfere with your normal version of Firefox. It will create its own profile, essentially. When you develop for the web, it will be very useful for you to use multiple browsers, okay? Because you want to be logged in as two different people, because you want to have a browser that looks in another way, and you don't want to have your usual bookmarks, because you want to have a clean slate from where to start, disable some extensions. So in general, you will see that knowing how to use incognito modes is very helpful. You can use them to log in as another person, to the same site in which you are, etc., etc. So I want to do, before I start building for the web, I want to explore a little bit how these tools work. So this is Chrome. In Chrome, I can go to anything I see. For example, I don't know. Suppose I wonder about this thing, I don't know, login via any Google account. I can shift-click here, and I can do inspect element. This opens the developer console, and I chose it to open as a separate window, but you can open it as part of the same window, okay? I prefer a separate window because I can see better. Sorry, I think the font might be really small. But this essentially contains, in this H2 element, there is login via any Google account, yada, yada, okay? And I can see the structure of the text here. This is a structure of the text of the page, okay? and you can open and close it. It gives you a way to browse everything that is there. Then you can browse the network. The network will tell you the timeline of what happens when you get a page. Now, I opened it too late, but let me reload. I reload these, and I switch to the network tab again, and this tells me everything that was downloaded, quite a lot of stuff, in order to build the homepage of CrowdGrader, okay? It tells me, sorry, I think that this we can move more in this way. It tells me all the, when you get a web page, you normally get a host of files. So you don't just get one. That was in the good old times. So now you get, one, and that file tells you what other files to get. And so in the end, you get a bunch of them, okay? So these are all the files that I got. And let's give it a look a moment, because it will be useful for us for debugging. So www.crowdgrader.org is sort of the main page. It is a GET request, and every request, so you have two types of requests, GET and POST. Actually, you have more than two types. So there is also PUT, but PUT we will not be using it very much. And I think that originally there was also DEL or something like that that nobody ever uses. Okay, so we will build with a GET and POST, and I will tell you later what the difference is. But so when you try to get something, you're executing a protocol in which you say, hey, please give me this thing that is at this URL, and you get a response that consists of some content and some error code and some return code. I will go to the content and to the format of what goes over the request in a moment, okay? But for the moment, the return code is very important. I'm sure you know 404 is page not found. 200 means that the content was found, and here it is. There are some very other important ones. So one of them is 304, not modified. A lot of content on the web is cached. These images on CrowdGrader, they're always the same. So I'm telling the server and Web2Py and the server environment that does some of it for you. It tells you, hey, this image doesn't change any more than once in a day or in an hour. So if you request the same image within that lapse of time, it will not send you back the image that would be bigger, right? It just says you 3 or 4, like what you had is still good. Okay. Now, when you do the request, you indicate as part of the request that you have it. Otherwise, it would be a dumb reply, because it would need to ask again and say, no, but actually I forgot it, no? But when you ask, you typically say whether you have another version of the page. Some pages are never cached, okay? Like the dynamic page of CrowdGrader, the home page is not cached. Because if you log in, this can contain actually the list of assignments or whatever it is, and this can change dynamically. So it's like Gmail, it's not cached, it's live, what you see. But all the Gmail, pictures, etc. is all cached. So you see here that I got the main page, and then I got this bunch of other stuff. And actually all the requests succeeded, and here you can see the delay. It loads in over 1 second, actually. I'm sorry, yeah. But most of the delay is, yeah, I don't know what it's due. I mean, I know, but I don't want to talk about it now, okay? But essentially, this is the network tab. In the sources tab, you can look at the source of all the JavaScript. Let's not get into that now. Timeline tells you you can record stuff. Now, let's look at it. The console is a JavaScript console. We will talk more about it when we will do JavaScript. But essentially, the web page can execute JavaScript. In this case, my web page, my home page is not doing any JavaScript if you are not logged in. But if there is any error, you will see it out in the console. And so this will help you immensely to figure out what you are doing. Okay, and you can also interrogate it for variables, etc. We will get to that later. So let's look a moment at how a request is done. So in CrowdGrader, if I click on these, it will give me details on the headers, on the response, on cookies, and on timing. The header means a request is formed of 2 parts, both the request and the response. Okay, so the request has and the response have headers, and then there is in general a body. that is attached to it. The headers of the request say, what is the type of encodings that your browser can accept? Okay, so these all tells, hey, I'm able to accept HTML content, I'm able to accept also some other stuff, etc., etc. You can give it to me normally, you can give it to me compressed with the gzip, you can give it compressed with deflate. You don't have to worry much about these things, okay, but they're there. Connection is keep alive, and then you give it a cookie. Cookie, we will talk about cookies shortly, maybe next time, because now the time is almost out, okay? Then you say which host you want, and you also say which URL you want. So you're saying what you want, okay? The status code is written here, but is actually, sort of part of the response. In the response, you get some information about what you are getting, and if you look at the preview, why there is no preview available? Boo. Maybe because it's not able to do a preview. Yeah, bizarre. Maybe it just does not want to preview my response. I'm not quite sure, okay? But so in this way, you can see exactly what the browser is requesting and what replies are coming back. This obviously is very useful, okay? Because, for example, if you, if there is any kind of error in how you serve the page, you would see it pop out of there, okay? So in Firefox developer version, this is very similar. So if you are here, you can also click inspect element, and you get a console that is very, very similar, okay? So this is the content of the page. One of the fun things you can do always is this. For example, CrowdGrader lets students, suppose you worry about this text, okay? Where is it? I'm having a little bit of a hard time finding it. Yeah, I'm more used to. Let me do it with Chrome. I just want to show you something. So log in via any Google account. One thing you can do is that you can edit the CSS and see the effect automatically. Okay, these are all the styles. We will talk later about how to specify the styles, but these are all the style elements that are applied to the particular text. And if I put here a bigger font, it will be bigger. So I just want you to be aware of these development tools, because they're the fastest way to experiment with a web page. You can even modify the content of the web page. Log in via any with any old Google account. Okay, so you can modify it and you can play with it. Of course, this is not stored anywhere. Okay, so but you can play with it to see how things look like to your heart's content, and then when you're happy with it, then you can copy what you did to the files that actually generate it. But I just wanted to show you this window into how the communication between browser and server actually works. And next time we will instead build an app slowly, explaining exactly how the browser communication goes is tied to the server responses and how that happens. Okay. Please subscribe to Piazza, because I want to send out some information and start telling you about homework 1.
Regarding the doodle, I have